Okay. Here we are going to discuss the solid state class 12 chapter. So in this chapter, first we are going to discuss about crystal lattice. Crystal lattice, or you can call what lattice space also. Lattice space. Crystal lattice or lattice space. So first, what is crystal lattice or lattice space? Okay, crystal lattice, one crystalline solid. We are discussing about one crystalline solid. Yes, here crystal lattice. Here, what is crystal lattice? The arrangement of lattice points. In three-dimensional space. In three-dimensional space is called lattice space. Lattice space or crystal lattice. Lattice space or crystal lattice. So what is crystal lattice here? The arrangement of lattice points in three-dimensional space. So in these points we can write what atoms or molecules or ions. Okay, the atoms or molecules or ions arranged in three-dimensional space. So such type of what space you can call lattice space or crystal lattice. So this is about crystal lattice or lattice space. Suppose I am taking one example here. This is one of the crystalline solid. This is crystalline solid. In this crystalline solid, there are some smallest portions, repeating portions are there. Smallest repeating portions here, smallest portions. So this smallest portion you can call unit cell. Yes, unit cell. This is one of the crystalline solid. In this crystalline solid, there are some repeating units. Such repeating units, what you can call unit cell. So what is unit cell first? Unit cell is the smallest repeating unit of crystalline solid. Okay, this is one of the crystalline solid. In this crystalline solid, there are some portions, small portions, repeating portions such type of repeating portions, what you can call unit cell. Unit cell is the smallest repeating unit. Repeating unit, what you can call unit cell. Just I am picking one unit cell from this crystalline solid, and I am drawing here. This is unit cell. Now we will discuss about this unit cell. Yes, what we are going to discuss about this unit cell? We are going to discuss how many corners are there in this unit cell, and face centers and edges. Here we are going to discuss about body center. Okay, and body diagonals, face diagonals. Okay, face diagonal. Here first, what you can call, this is one of the corner, 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 this is one of the corner. So this is corner. How many corners are there here? Corners. How many corners are there here? I am writing corners. Corners are 8. How? 1, 2, 3, 4, 5, 6, 7, 8 corners are there. The next term, faces. How many faces are there here? So this is one of the face. Yeah, this is one of the face. Okay, this is one of the face. and here right side and left side, above and below. This is above face, this is below face. The next front side one face will be there, then back side one face will be there. So total how many faces here? Total 6 faces are there. 6 faces. The next edges. How many edges are this? Edges. How many edges are there here? Here edges. So this is one of the edge, this is one of the edge, this is one of the edge. Once again I am drawing here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many edges are there here? Total 12 edges. 12 edges are there. The next, the atom present exact at center of the body. You can call what? Body center. Body centers. How many body centers here? One body center. Okay, if you draw from one end to another end through the body, so that here I am drawing one line. So this line, what you can call for this line? This is body diagonal. Body diagonal. Body diagonal. Okay, body diagonal. So this is what edges. Yes, these are the corners. So this is face. Okay, how many faces are there? 6 faces. How many corners are there? 8 corners. Then body center. This is body center. Body center. Okay. The next, the line from one end to another end in this unit cell. So what you can call this line? This is what? Body diagonal. Yes, I am drawing what in this face only. In this face only, if I draw one line from here to one end to another end in this face, so this is face diagonal. Face diagonal. Okay. In this unit cell, we just now we have been discussed about this. What corners we have been discussed? How many corners are there here? 8 corners. And how many faces? 6 faces. 12 edges. Body center 1. Then for this line, what you can call? Body diagonal. Yes, this line will be what? Throughout the body. So that's what here body diagonal. And drawn here in this face. So that for that what we can call? Face diagonal. So this is about what unit cell. This is unit cell. The next we are going to discuss about here number of means in this unit cell there will be some atoms. So those atoms will be at corners some atoms are there. At faces, face center some atoms are there. Yes, at edge center some atoms are there. Then how to calculate how many atoms? How to calculate that? Next we will discuss that. So the atoms will be occupied in this unit cell. The atoms will be occupied in this unit cell. How can we calculate that? How much percentage occupied atoms in this unit cell? That we will discuss next. Next we will discuss that. So here next we are going to discuss about next calculation of atoms, number of effective atoms, calculation of atoms, yes, number of effective atoms, or you can call what atoms, calculation of atoms. So how to calculate that? Here unit cell. So I am making one table here, unit cell, and next contribution of atom per unit cell. Contribution of atom per unit cell. Okay, contribution of atom per unit cell. Here corners, here body center, here face center, here number of effective atoms, so this here unit cell. Then I am taking now unit cell, that is simple unit cell. Simple unit cell. So in this simple unit cell, the atoms will be present at the corner of the unit cell. Only means the atoms will be present at the corner of the unit cell. Okay, simple unit cell. In simple unit cell, where are where these atoms are? So at corners. In simple unit cell. In simple unit cell, there is no body center, there is no face center atoms. There are no face center atoms. So simple unit cell, how many corners are there here? 8 corners total. 8 corners. So these 8 corner atoms, here 8 corners are there. Yes, 8 corners and 8 atoms are there here. Okay, these atoms, 8 atoms, the contribution will be 1 by 8. Why? Because so here these 8 atoms contribution means these atoms will be shared. These atoms will be shared with another 8 units. These atoms will be shared with another 8 units. So that's what here the contribution will be. The contribution will be 8 into 1 by 8 is equal to 1. Yes, here body center. There is no body center atom. There are no face center atoms. Yes, here number of effective atoms 1. This is about simple unit cell. The next we are going to discuss about here I am taking body center. Body center you can call what? BCC. So in this BCC, one body center atom will be there. No face center atoms. Corners are common in body center, face center, whatever. Okay, corners are common. Here body center in BCC, corners are 8 corners are there. Then these 8 corner atoms contribution will be 1 by 8. 1 by 8 is equal to 1. The next body centers, how many are there here? Body center, 1 body center, 1 body center, here 1 body center, 8 corner, its contribution will be 1 by 8. So we got one answer here. Then 1 body center here, so that's what 1 body center. No face centers, so no face centers here. Number of effective atoms 1 plus 1 is equal to 2. Number of effective atoms, how many are there here? 2 are there. Then next face center, FCC you can call. Face center, cubic unit cell. Then face centers, corners are common, I said in this. Corners are common, 8 corners are there. 8 corners, its contribution will be 1 by 8, then 1 atom. Then next, body centers. In this there no body center atoms, only face center atoms are there. So here no body center atoms and face center atoms. How many face centers are there here? 6 face center. 6 face center. So the atom present at exact center of the face. The atom present at center of the face, exact center of the face, you can call face center. What you can call? Face center. The atom which is present at exact center of the face, you can call face center. So how many face centers are there here? This is one of the face center, this is one of the face center, this is one of the face center. Front side 1 face center, back side of 1 face center. Total 6 face centers are there. 6 atoms will be there. So these 6 atoms here 1 face center will be there, here 1 atom is there. So above one unit cell is there, above 1 unit cell. So half of the part in that unit cell and half of the part in this unit cell. this atom will be shared half of the part above unit cell and half of the part in below unit cell. Means what is its contribution? Half of the part it will be shared with another unit cell. Are you getting my point? Then what will be its contribution? Here 6, half of the part will be contribution. So here what 2 ones are 2 threes are, then what we will get answer 3. Then here 1 we got corners, here 1 we got, then here 3, then 1 plus 3 how much? 4. Number of effective atoms in FCC 4. Yes. The next, this is very useful. When this is very useful when we calculate packing efficiency of simple cubic unit cell, body center, BCC, FCC. So there this what a number of effective atoms, 1 2 4, 1 for a simple cubic unit cell, BCC, in BCC 2 atoms, number of effective atoms, FCC 4 effective atoms. They are very useful, this one. So keep in mind this. Here this is what calculation of atoms. Okay. The next we are going to discuss about here next packing efficiency. Packing efficiency. Next we are going to discuss about packing.